Okay, so why does tan theta equal negative 2 have solutions? Well, tan theta, remember, in the unit circle, you can think of it as the slope of your radius if theta is measured as that counterclockwise angle. So the slope of this radius as it goes around, it could be really close to 0 like this line is. Whoa. It could be 1 like at 45 degrees. It could be almost infinity. It could be negative infinity. It could be negative 1. It could be negative 2. It could be negative 0.5. It could go all the way back down to 0. So tan theta can take on any value, right? So tan theta is the slope of the radius, which can take on any real value, right? Whereas sine theta equals negative 2, on the unit circle, sine theta equals the y coordinate, right? Where, to clarify that, right, if this is theta, then this y value here is sine theta. Okay, and on the unit circle, if you think about it, the biggest y value you can get is 1, and the smallest y value you can get is negative 1. So that means that sine theta has to be between 1 and negative 1. So there's no way to get sine theta equals negative 2 out of that, right? Let's say you didn't want to use the unit circle, and instead you just made any circle. So now this point is as high up as the radius or as low down as the negative radius. Well, in that case, sine theta equals y over r. Well, y over r, the biggest y you can get is r, and the smallest y you can get is negative r. Well, since the biggest y you can get is r, the biggest this can get is 1. And the smallest you can get is negative r. The smallest this can get is negative 1. So you're still locked in between negative 1 and 1. Okay? So, on the unit circle, sine theta is the y coordinate. I think it's easiest to do this using the unit circle instead of the y over r. And the greatest y value equals 1. The least y value is negative 1. So sine has to be between negative 1 and 1. And then you can say, okay, so there's no way to get negative 2 out of that.